We have seen bubble sort and selection sort. Now let us see insertion sort. Insertion sort remove one element from unsorted list in each iteration and grows the sorted list. Insertion sort finds the location of this removed element within the sorted list and insert that into its correct position. It repeats until input is completed. Like bubble and selection sort, this is also in-place sorting algorithm. In each iteration, it checks the value of the removed element against the largest element within the sorted sublist. Means this removed element will be compared with the element which is left to it. If this first element from the sorted sublist larger than this removed element, then algorithm will shift this larger value to one position right. Again, this removed element will be compared with next largest element within the sorted sublist. If it is greater than, it will also be shifted one position right. Same process will continue. If algorithm finds smaller element than this removed element, then this removed element will be inserted in its correct position. See here, suppose we have this sorted sublist and this is the unsorted sublist. First we need to remove this element from the input. So here it is removed. This will be compared against the largest value within the sorted sublist. Means this will be compared with this 8. 8 is greater than 2. So 8 will be shifted to right. Again 2 will be compared with 6. 6 is also greater than. So 6 will be shifted to one position right. 5 is also greater than 2. 5 will be shifted to right. 3 is also greater than 2. 3 will be shifted to right. But see here, this 1 which is not greater than 2. So this 2 will be inserted at this position after this one. All these 3, 5, 6, 8 are greater than 2. So all these are shifted to right. Now this 2 is inserted at this second position. This is the final list. This is the algorithm for above procedure for insertion sort. Here this I is loop variable for this outer loop. If you have n elements, algorithm will iterate for n minus 1 times. So this loop variable I starts from 0 and go up to n minus 2. Element at I plus 1 index will be removed and that is stored within this variable key. Here we are taking another loop variable j for this inner loop. This inner loop is to find the correct position to insert this key. If the element at jth index greater than this key, this array of j will be shifted to j plus 1th location. Then decrement the j. Suppose if no elements are greater than this key, then j will be decremented until it reaches negative value. If j reaches to minus 1, then this while loop will exit. This key will be inserted at 0th index because this j will minus 1 plus 1, it is 0. So key will be inserted at the first position. Same process will be repeated until all elements are sorted. This is the complete program for insertion sort. Here I am taking this array. Here n is the array size. Here I am calling insertion sort with this array arr and array size n. This function will be called. Here I use the loop variable for this outer loop. I will start from index 0. Now first pass will start. I less than n minus 1. So this array of I plus 1 means element at index 1 that will be removed from the input. That needs to be compared with maximum element within the sorted array. Here in sorted array we have only single element, that is the element at index 0. So j will be initialized with I value. Now j is also equal to 0. If this array of j greater than this key, this array of j will be shifted into j plus 1 location. Again j will be decremented. Now j is minus 1. In this condition here j greater than or equal to 0 will be failed because j equal to minus 1 now. So this for loop will exit. This removed element key now will be stored within the j plus 1 index. Here j is minus 1, so j plus 1 means at index 0. So this key will be stored at the index 0. Now first pass completed. After first pass completion, these two elements are sorted now. Again I will be incremented. So second pass will start. I plus 1 will be removed from the list that is stored within the key. Again j will be initialized with I value. Here I is 1, so j will be also 1. This array of j now compared with the key. Here array of j 6 greater than key 3. So array of j will be shifted to j plus 1 location. Again j will be decremented, so j will be 0. Again array of j greater than this removed element, so this 5 will also be shifted to j plus 1 index. Again j will be decremented, so now j is -1. Here this first condition will fail since j -1, which is not greater than or equal to 0. So this for loop will exit. Now key will be moved to j plus 1 index. Now j is -1, so this key will be moved to index 0. After completion of second pass, these three elements are in sorted order. Now third pass will start. Array of 5 plus 1 will be removed from the input list and stored in key. J is initialized with I value, so now j will be 2. This array of j will be compared with the key. Here array of j 6 greater than key, so array of j will be shifted to right one position. Again j will be decremented. Now j will become 1. It will be again compared with the key. Here array of j 5 greater than key. It is also shifted to right one position. Again j will be decremented. Now j will be 0. Again this array of j compared with key. Array of j 3 greater than key, so it will be shifted right to one position. Again j will be decremented. Now j is -1, so this first condition will fail, so this for loop will exit. Now this key will be moved to j plus 1 index, means this 1 will be moved to index 0. Again I will be incremented. Now fourth pass will start. Here also I less than n -1, so array of I plus 1 will be removed from the input. Again j will be initialized with I value, so now j is also 3. Array of j compared with the key. See here array of j 6, which is not greater than key, and j which is greater than or equal to 0. See here array of j 6, which is not greater than this key, so this for loop will exit. Now key will remain at the same position. Again I will be incremented. Now fifth pass will start. Element at I plus 1 index will be removed from the input. J will be initialized with I value. Here j greater than or equal to 0, and array of j which is 8 greater than this key 2, so array of j will be shifted one position to right. J will be decremented. Now j will be 3. Again array of j 6 greater than e2, so array of j will be moved one position right. J will be decremented, so now j is 2. Again array of j 5 greater than this key, so array of j this 5 will be moved to one position right. Again j will be decremented. Now j will be 1. Here also this array of j 3 greater than this key, so this 3 will be moved to one position right. Again j will be decremented, so now j is 0. See here array of j 1, which is not greater than this key, so this condition will fail, so this for loop will exit. Now this key will be moved to j plus 1 index. Now j is at index 0, so now this key will be moved to index 1. After completion of this fifth pass, all the elements are sorted now. See here we have two loops. This loop will run for n times and this loop will also run for n times. So this comparison condition, which is within the inner loop, it will run n square times. So insertion sort time complexity is big O of n square. Both the insertion sort and selection sort time complexity is big O of n square. But the fundamental difference between selection sort and insertion sort is insertion sort scans backward from the current key while the selection sort scans forward. So in selection sort, the first k elements are the k smallest elements of unsorted input, while in insertion sort they are simply the first k elements of the input, but these first k elements are in sorted order. The primary advantage of insertion sort over selection sort is the selection sort must always scan all remaining elements to find the smallest element within unsorted sublist. But in insertion sort, if k plus 1th element is greater than k element, no need to compare with other elements. Only single comparison is enough. Suppose if input array is partially sorted, insertion sort require very few comparisons compared to this selection sort. On an average, insertion sort require half many comparisons required by selection sort. The disadvantage of insertion sort over selection sort is insertion sort require more writes, means all greater elements needs to be shifted to right. But whereas in selection sort only single swap is required for each iteration. So insertion sort write n square times, but selection sort writes only n times. For this reason, selection sort is preferred if writing is more expensive than reading, such as flash memory.